Hello, my name is Andy Tusher, and I am a data scientist with the province of British Columbia. And I want to tell you today about the newest package that we've developed called bcdata, which is used to retrieve public data from British Columbia data repositories, especially spatial data. I've been working on this package for the last year or so with my collaborators Sam Albers and Stephanie Hazlitt, and yeah, I'm really excited to tell you about it today. Like I said, I work in British Columbia, in the capital, Victoria. If you don't know where British Columbia is, it's a really big province, almost 1 million square kilometers up in the northwest part of the continent, just above Washington State, southeast of Alaska. BC has a largely natural resource-based economy, and we have lots and lots of data. Not just about the natural resources, but all things in all topics that you can think of. But I work in the Ministry of Environment and Climate Change Strategy in a group called State of Environment Reporting, and we work on analysis and reporting on the status and trends of BC's environment. So we're big users of environmental data in the province. And we're also big proponents of open data and open science practices. Most of you have seen a variant of this slide before, taken from the Tidyverse cookbook, and it sort of outlines the sort of ideal workflow for reproducible data science, starting with importing your data, tidying it into a format that works, visualizing it, modeling it, transforming it, doing some analysis to get some meaning out of that data, and then communicating the results. And the thing that ties this all together, makes it a reproducible workflow, is that programming box that's around it. By writing all the steps of our analysis in code, it makes it a reproducible product that can be run by collaborators and reviewers. Unfortunately, all too often, accessing data and importing data, it kind of breaks this reproducible workflow because it's not always readily available. You may have it on your hard drive and no one else has easy access to it. You might have to email it to a collaborator, or you have to download it from a website manually to use it. And so that kind of breaks that scripted workflow, and so that importation step becomes a critical link. And if we can add it in the code, then we make the whole workflow reproducible. So I want to do a quick introduction to the British Columbia Data Catalog. It is BC's online repository of all the public data that we host. There's thousands of data sets, close to 3,000 at last count. Most of them are available under an open license, which means that anybody can download that data and use it for whatever they like with very few constraints. And it's got a raft of both tabular and spatial data. And it's got great interfaces for downloading the data. So if you have, if there's some spatial data that you're interested in, there's a great GUI where you can select your coordinate system, select your output format, select your area of interest, and you can download really, really big spatial data files from the catalog. So it works great. But, and kind of as I alluded to earlier here, there's a bit of a problem in that not getting the data in your code breaks that reproducibility. It can't be scripted, and so it's not repeatable. So, the manual process is not ideal. But luckily, there are APIs that sort of back all of the catalog stuff, and they're publicly available. There's two key ones in particular. There's a catalog API, which allows you to access and search and retrieve metadata, as well as many tabular data sets from the catalog. And very powerfully, there's also a web map library API that has both an image overlay web mapping service, and really powerfully, it has a web feature service, which is a service that allows you to download the actual features themselves, the points, lines, and polygons, as well as all the attributes that go along with them for some really, really big data sets. And it has a really flexible query interface via REST API so that you can get just what you need. As many open source projects go, this started to as a means to scratch your own itch. So the three of us were sitting down one day, and one of us said, "Hey, there's a great API for accessing spatial data from the catalog. I wrote a function, and it works pretty well." Someone else said, "Hey, I just discovered that and wrote my own too the other day." And the third person says, "Hey, I need that." And so obviously it was a catalyst for collaboration and to sort of sit down and turn this thing into a package that could be more widely used. All of the functions of bcdata are preceded by a bcdc underscore prefix to facilitate autocompletion. There's a search function and there's a get record function that are sort of around querying and searching for the metadata. Today I want to focus on getting data and how that can enable a reproducible workflow, and most specifically about spatial data. So for a quick demo, I want to just pull up a data record that everyone can probably relate to on BC schools and the programs that they offer. So here's an example of a catalog record. A record is sort of the metadata around a data set, and it often comes with one or more, well, it always comes with one or more resources, which are the data themselves. And so here the record is the programs offered in schools, and the resources are these two files here. There's a comma delimited, tab delimited text file and an Excel file. And so we're going to get the text file because it's sort of a more open standard. So we're going to use our bcdc get data function, and from the catalog page or from the bcdc get record function, you can get sort of a unique ID for the record and the resource, and you specify those in the get data function, and it will hit that API, determine what kind of data you're downloading. Most of the times it will find the correct import function and bring in a nice table for you. So in this case it brings in a data frame of schools across the province and the different services that they offer. So just a brief example of getting tabular data. But really the sort of the most exciting piece from my perspective is the ability to get that spatial data, and not only to get it but to query it. And so the workhorse there is the bcdc query geodata function, and it hits that WFS, the Web Feature Service API, to get sort of fine-grained access to geographic information at the feature and property level. So it allows us to query that data and get just what we want. When we run this function just by itself, similar to dbplyr, if you've used it to interface with data frames using a dplyr syntax, when you run this function, it doesn't actually get the data right away. It gives you a promise, which is a sort of an object that tells you this is what you're going to get when you eventually finish building your query and asking for the data itself. So if you run that function by itself with the name of a record, so here we're looking at municipalities in the province, it gives you the message saying collect. Using the collect function will return 161 features and 20 fields. And at most 6 rows of the record are printed here. So it gives you a little preview of what you'll get if you run collect at the end of your pipeline. So again, if you're familiar at all with the dbplyr framework, and dplyr in general, we can sort of run bcdc query geodata and pipe that into select. So we can use that to select just a subset of columns that we want. And it works with all the tidy select helpers. So starts with, matches, one of, etc. Here we're just selecting two columns, the admin area abbreviation, admin area group name of those municipalities in BC. And again, this isn't actually running the query and downloading the data for you, but it's giving you a preview of what you'll get. So we still have 161 features because we haven't used filter, but we're only getting 5 fields now, 5 columns. And we get 5 because there are even though we asked for 2, there's always a few sticky columns that come along for the ride, and those are sort of the important object IDs and similar identifiers for the rows. And we can get rid of those later if we really don't want them. So after running select, we can pipe that into filter, again, just like dplyr and dbplyr. And here we're just using a standard logical, using the double equals to say, give me all of those rows, all of those features that have an admin area group name of capital regional district. And so that is the regional district in which I live. Regional districts in BC are like counties in the United States, so sub-provincial geographic agglomerations. Again, we haven't run collect, so we get another message saying this is now going to return 13 features because there are 13 municipalities within the capital regional district. And those 5 fields, the 2 that we asked for and the 3 that we didn't, but we have no choice to take. So finally, we've finished building our pipeline, and we say we want the data now. So we just tag on collect to the end of the pipeline, just like in dbplyr. Interfacing with a database, and it will send that query to the web server. It will run it, and it will download just those features and just those columns that we asked for and return it as an SF object. And so now we've got a real SF object. We've got 13 features, 6 fields. It's a multi-polygon, and this is something that we now know how to work with in our normal workflow. And just to show that we've got what we asked for, this is the capital regional district with the boundaries of the 13 municipalities that are within it. I live down in one of those southern ones in Victoria. And so that's all awesome. So we've offloaded a whole bunch of work to the server. We're getting data that we want. We've filtered rows and we've selected columns. But we can also filter based on geometry. So WFS allows doing geometric operations using the sort of standard set of logical geometric predicates that many of us are used to using, such as intersects, equals, within, contains, overlaps, all of these sort of geometric comparisons. And so what I want to do now is show you how we can take that CRD municipalities object that we just created, which shows just the municipalities within the capital regional district, and use that to get all of the green spaces, the parks and protected areas that are within that regional district, within the capital regional district, using these geometric predicates. So I'm not going to show you the catalog record for it right now, but there's a record of local and regional green spaces. So we put that ID into our bcdc query geodata function. We can pipe that into select to just get the columns we want, park name, park type, and the primary use. And then we can pipe that again, and this is the great part, into filter. And instead of using a logical predicate, we're using a geometric predicate. So we're saying, just give me those green spaces that intersect the CRD municipality. And so remember that CRD municipality object, CRD mun, is an SF object. And so that goes along with the query. We run collect on this. It sends the whole shebang to the server and does the processing, finds the green spaces that intersect with that object, and just downloads those ones that we want. And so now we can plot those on top of our CRD municipalities, and we can see that we just have those dark green places, those nice parks that intersect the regional district that I live in. So just to recap, bcdata is a new package that provides access to thousands of data sets from the BC catalog directly within R. It's a novel interface, as far as we know, to WFS service using this familiar dplyr syntax and a sort of a new dbplyr front end to a web service backend instead of a database backend. It allows you to perform spatial and non-spatial queries to just get the data that you need and incorporate that into a reproducible spatial analysis workflow. So I just want to give a great big shout out to Sam and Stephanie, who worked really hard on this with me, the data catalog team, who have answered millions of questions for us about how the APIs and the data are all structured and how they all work, and especially to our employers for encouraging us and allowing space for innovation and collaboration. Finally, bcdata is on CRAN. You can use the install.packages to get it. We have a package down site at bcgov.github.io/bcdata. We've got some nice vignettes on there. Please file any issues or bugs you find on the GitHub page. And hit myself, Sam, or Steph Hazlitt on Twitter. Those are our handles. And find us on GitHub as well. So thank you very much. I hope everybody's enjoying their virtual St. Louis useR conference. And I hope to see you at a future one.